Hey there, period 3. We didn't get to these notes today, and so I wanted to make sure that I got them written out, and I wanted to send them to you. So what I'd like you to do is to watch this video and fill in these notes. We're just going to do 2 pages here, and I'll go as quickly as I can. So I've been talking about erosion. That's our topic of today. And so erosion is a transition or forces or materials that are going to transport those sediments, and the agents of erosion include water, wind, glaciers, waves, and gravity. That's how far we got. So let's talk about erosion by gravity first. So when we're talking about erosion by gravity, the first thing I want to talk about is this thing known as mass movement. So mass movement is the downhill movement of sediments by really gravity alone. And here are the types of mass movement. So first of all, you've heard of this before, mudslides and landslides. So those are mudslides right there. Those are landslides. Landslides and mudslides are essentially the same thing. It's just that mudslides will have water will help that process, whereas landslides are typically without water. And then we have creep. So there's creep right there. Creep is the really the slow movement of soil sort of downhill because it's on a steep slope. And then the last one is slump. And slump is just like when a bunch of soil just kind of like settles in to the landscape. You see this real steep surface right here. It gets undermined in some way, and all that sediment just kind of like slumps down. Next, let's talk about erosion by wind. Wind erosion is the most effective where sand, silts, and clays lie loose and dry and unprotected from natural vegetation. Wind erosion is the most common in arid climates. And arid, if you remember, means dry. So there's, these are places where there's no natural vegetation, sand, silts, and clays. There's nothing to hold them in place. There's no roots to hold them in place. There's no water to weigh it down. And therefore, these light sediments can easily be carried along by the wind. Number 2, this is a relationship statement. As sediment size increases, as we go from some clay to silt to sand to pebbles to cobbles to boulders, the amount of erosion by wind decreases. So as the sediments get larger, less likely to be blown around by the wind. So that's pretty obvious. It's pretty logical. Number 3, you've seen this word before, abrasion. So abrasion is an agent of erosion by wind. It's the process of erosion produced by the suspended particles that impact on solid objects. Wind-blown grains of sand carried along at high speed are a very effective tool that can sandblast away rocks. And this image down here is just showing wind moving from the right to the left and blowing sediment particles with it, impacting rocks that are there. So wind is a agent of erosion because it's carrying those sediments. That's page 8. Let's turn over to page 9. Erosion by streams, or erosion by just plain running water. So streams or running water is the most dominant form of erosion. Most dominant form of erosion. Nothing on earth transports more sediments than running water does. In the video that we watched today about the Grand Canyon, they were saying that the Colorado River carries 500,000 tons of sediment every single day. That's a lot of sediment. So it's the most dominant form. This right here is a definite test question. You can count on it. Let's write that down. On test. Now the amount or the volume of water flowing in a stream is referred to as the stream's discharge. That's its discharge. The primary factor that affects discharge of a water in a stream is the amount of rainfall that area receives. So obviously more rain that there is, the more it's going to flow into the rivers and streams, increasing its volume and therefore increasing its discharge. Very logical. Now, therefore, the water cycle plays a major role in the volume or in the discharge in a stream. So down here we have the water cycle. We have an image of the water cycle, and it's numbered 1, 2, 3, 4, 5, 6. Let's talk about this. We're going to fill in this diagram here, and then I'll ask you about it on your next quiz. So number 1, so the sun provides energy, sends energy to the earth. That energy is absorbed by the waters of the earth, and the water will absorb enough energy to the point where it changes from liquid water into water vapor in the process that you know as evaporation. Now, evaporation can also come from plants, trees, grass, meadows, whatever, and then when water is evaporated from the leaves of plants to get water vapor, that's known as transpiration. So number 2 stands for transpiration. Every once in a while we run into this word. It's a combination of these two words. It's called evapotranspiration. And evapotranspiration is just simply all of the ways that water gets evaporated into the atmosphere from the water and from plants. Now, when that water vapor gets into the atmosphere, it rises, it cools down, and it condenses to form clouds. So 3 is condensation. Condensation. So clouds are actually very, very tiny droplets of water, and sometimes small ice crystals, because it's pretty cold up there. It's easy to get below freezing, especially if the air temperature near the land is close to freezing. Now, if the water droplets get to be too big, they fall back to the earth, or if the ice crystals get to be too big, they fall back to the earth. So, and whenever water is falling in any form, we call that precipitation. So precipitation can be rain, precipitation can be snow, can be sleet, can be hail. Any of those are fine. Now, once that water does hit the surface, then it's going to do one of 2 things. The first thing it can do is it can land on the ground, flow into a creek or a stream or a river, and then flow back downhill towards the ocean. This is known as runoff. And we'll talk later about what's going to increase or decrease the likelihood of runoff occurring. Or what could happen is that precipitation can seep into the ground at 6, seep into the ground and become part of the groundwater table, which is just an extension of water at the surface. And that's known as infiltration. And then it could get stored there, or it could flow out back into the oceans and then get evaporated again. But down here, this is where this all starts all over again. Okay, that's as far as we got on the notes today, so make sure you write these down and be prepared to know this material for your next quiz. Okay? Talk to you later.